All right, guys, we're going to get started with these graph translation notes. The first thing we want to do is we want to take the graph in front of us and we want to divide it up into specific types of motion. So right here, we can see that from here to here is one type of motion. And then from here to here is another type of motion. And then from here to here is our third type of motion. And lastly, we have from here to here as our fourth different type of motion. So let's go ahead and describe what's happening along those different points. So from 0 to 2 seconds, I see I have a line that's sloped downward. Because it's down, it's going from 8 meters to 2 meters. That's going to mean that I'm moving towards the origin. So I'm going to go ahead and write towards here. And then also the fact that it's a slope line means that I'm moving at a constant velocity. So towards the origin at a constant velocity. Let's take a look at our second line here. Starts at 2, ends at 4. We can see that this one's at 2 meters. And it continues at 2 meters the entire time. So that one is going to be stopped or at rest. Stopped, at rest, or not moving. All right, and then our next part, we have line 3, goes from 4 seconds to 6 seconds. We see it's a curved line. Because it's a curved line, it's going to mean that it's accelerating. And we see that it's curved upward, meaning that the slope is getting steeper and steeper and steeper, which just means that we are speeding up. So this is going to be speeding up. And we can see that we're starting at 2 meters over here, and we're speeding up to 8 meters. So 2 to 8, that's going to mean speeding up away from the origin. Our distance is increasing. All right, and here's our last part here. We have from 6 seconds to 10 seconds. We're going from 8 meters all the way up to 16 meters. So 8 to 16 meters, distance is increasing. That's going to mean that we're moving away. And the straight slope line means that we're moving at a constant velocity.
Now that we're done describing the different types of motion qualitatively, we're going to look at them quantitatively by finding the slope of each different type of motion.
So let's start with line number 1. So line number 1, the slope, right? We should know that slope is just equal to change in y over change in x, right? And that's just rise over run. So in this case, our y value would be 2. So y2 is 2, y1 is 8, 2 minus 8, and then over x2, which is 2, x1, which is 0. So we have 2 minus 8 over 2. That gives us negative 6 over 2, which gives us a slope of negative 3. Don't forget the units, meters per second. Okay, so now moving along, let's look at line number 2. Well, line number 2 is super easy. It's a horizontal line. So if we were to figure out the slope of a horizontal line, we could just skip it and say that we know that the slope is 0 meters per second. But if we want to figure it out with math, we just get y2, which is 2, y1, which is 2, over x2, 4, minus x1, 2. We end up with 0 over 2, which is just equal to, like we said, 0 meters per second. Which means, again, our velocity is 0, meaning that we are not moving. So now let's take a look at our next line. We see line number 3. So line 3 is interesting, right? Because it's a curved line, that means that the slope is always changing. If we have a line where the slope is always changing, we're not going to be able to figure out what it is at any one point. So for this one, we're unsure. We don't actually know what the velocity is, because like I said, that velocity is constantly changing on that line.
So we're not going to be able to figure it out.
So now let's take a look at line number 4. Line number 4, our y value is 16 and 8. So we'll write that up here, 16 minus 8. And it's happening over the time interval of 10 and 6. So I solve here, I get 8 over 4. That gives me a velocity of 2 meters per second. All right, so now we're going to use the information that we just got above to make a velocity versus time graph. After we broke our displacement versus time graph up into similar parts of motion, we then figured out the slope at those specific time intervals, and we're going to use that information now to create a velocity versus time graph. So our slope tells us velocity. So now we know that from 0 to 2 seconds, our object is experiencing a velocity of -3 meters per second. So I'm going to go to -3. I'm going to draw a horizontal line because we said it's a constant velocity. And I'm going to make that from 0 to 2 seconds. Then I'm going to do the same thing for my next time interval. That's 2 to 4 seconds, and it's experiencing a velocity of 0 meters per second. So again, horizontal line because it's a constant velocity. I don't know what's happening from 4 to 6 seconds, so I'm going to leave that blank. I'm going to skip over it and go to 6 to 10 seconds. So from 6 to 10 seconds, my object is experiencing a constant velocity again of 2 meters per second. So I'm going to go ahead and draw my line here. And then now all I'm missing is my 4 to 6 second velocity. We said that that velocity is speeding up. So what we're going to do now is we're just going to go ahead and connect the dots. So we're going to connect the end of our 4 seconds to the beginning of our 6 seconds, which makes sense because this line right here is saying exactly what we said we wanted it to say. This line means that we're speeding up away from the origin. After we've graphed all the slopes that we found out from our displacement versus time graph onto our velocity versus time graph, because again, the slope of displacement versus time is velocity, we can go ahead and check this graph by looking back at what we said the motion looked like on that displacement time graph. So if I look, I said from 0 to 2 seconds, my object had a constant velocity towards the origin. If I'm looking at my graph over here, I see that this is experiencing a constant velocity, horizontal line, and it's moving towards the origin because it's under the x-axis. It's a negative velocity. Then from 2 to 4 seconds, I can see that my object is standing still or not moving because it has a velocity of 0 meters per second. Next, from 4 to 6 seconds, I can see that my object is moving away because it has a positive velocity. It's going from 0 to 2. And I can also see that it's speeding up because, just like I said, the velocity is going from 0 meters per second to 2 meters per second, as in the velocity is getting bigger, meaning that I'm speeding up. Lastly, I can see that from 6 to 10 seconds, my velocity is constant. It's staying at 2 meters per second, and it's also moving away from the origin because it is a positive velocity. So again, just double checking with what I said before. I said that 0 to 2 seconds, constant velocity towards, check. I said 2 to 4 seconds, at rest, not moving, check. I said from 4 to 6 seconds, I'm speeding up away, check. And I said from 6 to 10 seconds that I'm moving at a constant velocity away, check. The main takeaway here is that we need to divide our graph up into separate parts of motion, take the slope of those separate parts of motion, and then transfer that slope to our velocity time graph because the slope of our displacement time graph is velocity.